Okay, so first we had to correct one question from exam 1. So I chose question 7, and it said that you have to show that S is a linear transformation. And in order to do that, a linear transformation has two properties you need to prove. So T of U plus V has to equal TU TV, and T of CU has to equal C of TV. So first I needed to show that this would equal this. So I plugged in the first column and the second column, and I got this equation, and I was able to rearrange everything so that this could be this. So condition 1 was proved, and then I had to show that T could be taken out as a scalar. So I plugged in T times A and then T times B and TC, and then I got this. I was able to pull out the T, and then I was able to write it like this, so condition 2 is proven. Both conditions were satisfied, so S is a linear transformation. And then question 2, we had to prove that H was a subspace. And to do that, we need to prove 3 properties. The first one is the zero function. If you let A and B equal 0, then you get 0. So that's satisfied. And it needs to be closed under addition. So I let U equal this and V equal this. And then when I added U and V together, I got this. And I had to find A prime to be A plus C and then B prime to be B plus D, and got this. These are still real numbers, and this means that V plus U plus V is an H, and then it needs to be closed under multiplication. So I said C is a scalar, and U is equal to this. So then CU of X equal this. I let A prime equal CA, B prime equals CB. So that means CU of X would equal this, which means that CU is an H, thus H is a subspace. All the properties were satisfied, so that means H is a subspace. And for number 3, you had to find the dimension of the subspace, and the dimension is the number of vectors in the basis for H. So first I found the basis. You find the basis by taking out the linearly dependent vectors, and you do that by setting up a homogeneous matrix and finding the solution. And x3 is the free variable, and that means there are multiple solutions, so it's not linearly independent. So you can just get rid of column 3 to make the set linearly dependent. And this means the basis has 2 vectors in it. So the dimension is 2. Alright, and then for part A, it says that A is a 2x2 elementary matrix formed by performing a row replacement on the identity matrix. And we have to prove that the determinant of A is 1. So I found A by doing a row replacement, and then I found the determinant, and it equaled 1. So part A was satisfied. Alright, and then you have to do let B equal this, and then A would equal this, and you have to calculate AB and take the determinant, and then you have to calculate the determinant of A times the determinant of B and get the same determinant. So I calculated AB and got this. And the determinant of A is 1, and the determinant of b is this. And when you multiply these two together, you get the same thing. So yes, the determinant of a times the determinant of b equals the determinant of ab. Alright, and then for part C, it says that A is a 2 by 2 elementary matrix formed by swapping two rows of the identity matrix. So I found A by swapping the two rows. And then you got the determinant of A is -1, which is what we had to show. Alright, and for part D, we had to let B equal this. And A was created by replacing row 1 with row 2 on the identity matrix, so we got this. And then we had to show that the determinant of A times the determinant of B is equal to the determinant of AB. So I found the AB, and that was equal to this matrix here. And the determinant of that was this. And then you have the determinant of A, which is -1, which we found in the last question. And then the determinant of B, which is this. And if you multiply those two together, you get the same thing as determinant of AB. So yes, the determinant of A times the determinant of B equals to the determinant of AB. And then for part E, A is found by doing a scalar of any of the rows. So I scaled the first row by k and got this. And then I found the determinant of A, which is k. And that's what we had to prove or show. Alright, so now we have to let B equal this. And A was found by doing a scale of k by row 1. And we had to calculate AB. And we got this. And the determinant of AB is this. And the determinant of A times the determinant of B equals k times this. And we get the same thing. So the determinant of AB is equal to the determinant of A times the determinant of B, which is what we had to show. And that was it. Thank you for your time.